Over the last decade, the field of quantum computers has exploded. We've seen that with software, hardware, and algorithms.
Many of the key challenges in quantum technologies are actually of an engineering nature.
In order to transform quantum technologies to be usable out of the laboratory, we need to have compact and robust key technologies.
It's really fascinating getting to use these new high-tech solutions and kind of see what the limits of it are.
QUARTIQ is a small company in Berlin, Adlershof. We provide services in 3 key areas. We provide hardware, we provide software, and we transform ideas into industry-quality algorithms for controlling quantum technology. Our products are unique because they are developed in an open-source fashion. We collaborate with partners in academia and in industry to build a system that contains dozens of modules for all kinds of applications. One of our products is the Sinara hardware ecosystem that allow control all the way from nanoseconds to years.
Some of the products of QUARTIQ include high-performance signal sources for which we build custom gateware, so custom high-performance integrated circuits that compute these signals on the fly, which then the ARTIQ software on top makes use of to produce signals for quantum experiments.
ARTIQ is a complete software stack, all the way from the gateware to the graphical user interfaces.
The work we're doing at QUARTIQ is really interesting because it's a lot of open-sourced, embedded Rust development work, and it's really fascinating because Rust is kind of a new language that's entered the scene in the last few years, and it provides us a lot of possibilities, especially in the safety-critical sector, where leveraging Rust we can employ these new features like memory safety and prevent whole classes of defects, and it's just a really fascinating approach where kind of everyone's benefiting from this open-sourced ecosystem.
The work we do together with our key partners is important for QUARTIQ because it allows us to see how our projects are being used in the lab and in practice. For example, the National Metrology Institute in Germany, the PTB, and the OptiClock project.
Our group here at PTB is focused on the development of next generation atomic clock based on optical transitions of trapped ions. And here support from QUARTIQ was important to setting up, based on our specifications, an optimized version in terms of hardware and software for controlling that system. So it allows us to focus on research. And for the students, it's very helpful because they get a platform in which they can develop, and they want to set up such an experiment. And there QUARTIQ supports us with specific support for soft and hardware.
Another key collaborator is the Humboldt University in Berlin and the Solis 1G project.
Our group is a joint laboratory between these 2 institutions. We share the very same fascination for all the wonderful things you can do with atomic gases on the one hand, and advanced engineering and microintegration technologies on the other hand. And that is a very good combination because our goal in the group is to develop the next generation of integrated atom-based devices for timing, field sensing and communication applications. Our next milestones together with QUARTIQ would be to first of all demonstrate an optical clock operation in the laboratory, and then to demonstrate this technology in space on a satellite.
QUARTIQ products are unique because they offer one solution for every problem that you have in a lab where you use cold atoms. And in the near future, a scientist just pushes the button and QUARTIQ's electronic is doing the rest, and the scientist can concentrate on science.
QUARTIQ is different from other companies. We are part of a community where everybody can contribute and where everybody can change and modify and redistribute the designs. We are looking for enthusiastic colleagues that are open to the challenges of quantum technology.
For young physicists and engineers, QUARTIQ offers a very interdisciplinary working field. For me, there is the opportunity to apply cutting-edge open-source tooling in a very interesting up-and-coming field.
The work atmosphere at QUARTIQ is really interesting because it kind of combines this scientific style of debate to find the best solution possible. And so there's some really constructive and beneficial debates that kind of happen in the software design process, and I find that really contributes to developing good software.
The visions for QUARTIQ in the future and in the long run are to realize more exciting projects with our partners in academia and industry and to expand our collection of hardware modules and software.
Our hope for the future is that the collaboration with QUARTIQ will enable us to achieve the required robustness that is really necessary for quantum technology to find application in industry.
We have the joint vision of making quantum technology a reality. So we would like to have society and industry make use out of our sensors and timing devices we build together.
For the future, I hope that QUARTIQ and our collaborative open source approach can become a foundational part of the second quantum revolution.